Okay, so for 8-2 today, we are going to divide powers with our like bases. So yesterday we multiplied. Today we're going to divide. And we're going to simplify these algebraic expressions with some negative exponents. So the quotient property of exponents can be applied to algebraic expressions. So it says to divide with like bases. Okay, so when we divide with like bases, we what? Subtract the exponents. And that's what this is showing. Okay, so the exponent on top, just like division, the exponent on top has to come first. Okay, so that's why we have the a is in the numerator, the b is in the denominator, why we have a minus b. Okay, that's pretty much it to get us started. So it doesn't matter if we look at our examples. Okay, example 1a, we have a division sign instead of the bar. You could rewrite it to have 32a cubed divided by 4a. Doesn't matter how you want to do that. But I want to show you why this is the case. So if we look at this, this is going to equal 32 divided by 8. No. See, again, my brain works faster than my hand does a lot of times. So 32 divided by 4. Okay. Then we have times, we have 3 a's. So I'm going to show it to you this way. I'm going to show you it's a times a over, and there's 1a in the denominator. Okay? Hopefully this will help you see why it is subtraction. Okay? So what we've done in the past to solve these is we would cancel numerator and denominator. 4 goes into 4 once, 4 goes into 32 how many times? 8. Okay? So this is, so this is equal to 8, and then we, why the second? Well, we are subtracting, but why can you tell me that it's that it's a to the second using this? Because an a in the numerator and an a in the denominator cancel, and we're left with 2 of them. So it's a to the second. You're right. But again, like I wanted to show you why it is subtraction. You're right, Cameron, that it is, because this would have been the same thing as 32 divided by 4, a to the third power minus 1. If you just wanted to write it out like that, because there's 1 here. We don't ever write the 1, but it is 3 minus 1. And that's going to get you 8a squared as well. But I wanted you to see it a little drawn out so you understood why. Okay, so how about b? It's already written as a fraction. So we can go ahead and cancel maybe. Do 24 and 8 or negative 8 cancel at all? Yeah, okay. It'd be negative 3. Sorry, so there'd be 3 here and this would be 1, right? Like the negative 1. So I just wrote that as negative 3. Okay. So then we have some x's. So we have how many x's in the numerator? The numerator is the top. 2. Do we have any in the denominator? 1. So it's going to be x2 minus 1. Because 24 divided by negative 8 is negative 3. Yeah, it's a negative 8. So we get the 2x to the 2 minus 1. Okay. Then we have y to the 6 in our numerator. Do we have any y's in the denominator? Yes. How many? 2. So we're going to say 6 minus 2. And then I have z to the 7th in my numerator. Do I have any z's in the denominator? Yes. 5. So I'm going to do what? Minus 5. You got it. Yep. And then we just simplify it from there. So negative 3x to what power? To the first power, so just x, y to the 4th, and z to the 2nd. That's the answer. That is it. That's fun. Yeah. It is cool looking, just not extremely helpful. All right. Okay, so that is it. Negative 3xy to the 4th, z to the 2nd. Right, but like So here's the thing. This is like, example 1's always like your reminder. Like, hey, maybe you've seen this before. Let's ease into it. And then it's like, okay, now you're freshmen in high school. Let's get a little harder. So yeah, the first ones are always a little easier. You're right. Only if you want to live at home and the rest of your life can you go backwards in math, really. So good try. All right, so now it's going to get a little different. We can have negative exponents, okay? So negative exponents indicate a quotient. So if you have x to the negative n, okay, it's actually 1 divided by x to the n power. Okay, so the negative just means, hey, we need to move this term to the denominator. Or it could be in the denominator and we need to move it to the numerator, but we need to move it. Good. Okay, so a quantity with a negative exponent is equivalent to the reciprocal of that power with a positive exponent. So again, if it's in the denominator, down here, and it has a negative exponent, we're going to move it to the numerator. Whereas here, it was in the numerator, or it was regular, and we had to make it a quotient. That's all it means. Okay? The other place. Yeah, right? We could say, maybe that's it. Like it's the reciprocal. No, it's just the reciprocal. It's not the opposite reciprocal, like when we were doing things before. Okay, it's just the flip of it, the reciprocal. All right, so it says, example 2, write an equivalent expression in positive exponential form. So here's our trippy one, right? That's got the -4 there. So the glitchy board. I don't know why. I mean, like, it really only glitches in your all's class. I used it perfectly fine all day yesterday, except in your all's class. Okay, but I also think maybe there's a short, because when I stand over there is when it glitches the worst. So I'll try not to do that. Okay, so, okay. Well, it's already in the top. So we need to make a fraction, right? We need to make a fraction and put a 1 in the numerator and x to the 4th underneath. Okay, so the y squared is still perfectly fine, right? So I'm just going to write y squared here. So where would we put the y squared? With the 1, yeah, it would go in the top. So if we simplified this, we would have y squared over x to the 4th. That's it. So right now we're just moving things around and shifting them, and that's kind of it. Oh, cool. I like it. Oh, cool. Okay, so how about in B, 2x to the -2 power? Okay, what does the -2 apply to? Not the whole thing. Just the x. Nope, because it's only, if there's no parentheses, remember it only goes to the number after it. So the 2 stays, or we'll put it on the top. The 2 stays, or it goes on the top, and then you're going to have 1 over x squared for that section. So these are being multiplied. So as Abigail said, the 2 goes on the top, and then we have x squared on the bottom. Because your 1 and your 1 would cancel out with your 2 because you multiply. Well, yeah, because you multiply. 2 times 1 is 2. Good. All right, so C has a few more steps to it. What does the 3 apply to here? The 3 applies to everything. Yeah. Everything. Okay, so we need to do that exponent first. So we're going to have -3 cubed, and then we're going to have, actually, let me write that a little bit differently. Okay, then we're going to have our x to the -2 to the 3rd power. Because remember, when it's a power to a power, we multiply it. Okay, so that's going to be x to the -6. It's going to be -9 x to the -6. Not -9. -3 times -3 is a +9, but we have to do another times 3 because it's cubed. 9 times negative 3.
It's going to be a negative 27.
Negative 27. So that is correct. Except wait, I still have a negative exponent and I'm supposed to write it with a positive exponent. Dang it. So how would I do that? Nope. I just put it in a fraction. Which part goes in the fraction? That you got it. So it'd be 27 over x to the 6th. That is correct. So see, now we can do it a little quicker. We don't have to necessarily see this step. We're recognizing like, oh, this is what happens. It just moves down to the denominator. Okay, perfect. How about this last one? What's the negative 2 apply to? The whole thing again. So I'm going to have 1/3 to the negative 2 power, and then x to the negative 3 power times negative 2. Which is a positive 6. Where are we getting 6? Put in your calculator. Okay, so it's 2 negatives equal a positive. Okay. I was like, what?
So 1/3 is to the negative second is 9.
Okay, so we have a negative exponent, right? When we have a negative exponent, we have to take the reciprocal. What's the reciprocal of 1/3? 3 over 1. And so this is 3 over 1 squared. I got rid of the negative. Okay, so we took the reciprocal. Okay, and then negative 3 times negative 2 is positive 6. Okay, so what's 3 over 1 squared? 9. So this would be 9x to the 6th. Good. But this one is definitely like, it's this part right here that's kind of trippy. We hadn't seen one like that. Okay, but remember, the rule is we have to take the reciprocal. So if we have a fraction, we just take the reciprocal of it. Very good. You guys are flying.
Yeah, just wait till we get back.
Oh, you're going to be okay. I think you're going to get it.
All like a trap. The math lesson lures you into thinking it's easy, and then you get to the back.
Okay, so let's remind you, only like terms can be added. Okay, when you are simplifying, only like terms can be added, is our reminder. Now, the other thing that's a reminder up here, it says x is to the power of 0 is equal to 1, always. And it's showing you because, or since, x cubed divided by x cubed is equal to x to the 3rd power minus 3, which is x to the 0 power. Okay, so that's an x to the 3rd divided by x to the 3rd equals 1. Okay. This is why, because they all cancel. So, example 3. We want to divide 34x to the negative 3rd, y squared, z to the negative 5th, by negative 18x to the negative 6th, y squared, z to the negative 2, and express your answer in positive exponential form. So we want positive exponents is what that means. So here's the thing. Do you want to write it out as a fraction, like the whole thing, or do you just want to piece it together as we go, like we had been doing? Just piece it together? Okay, because we are dividing. So we're going to have 34 divided by what? The negative 18. You got it. And then we have x to the negative 3rd. And we're dividing, so it's going to be minus what? Nope, it's got to be the x. Okay, so minus negative 6. Does this make sense? Are we following along? What did you say, plus? Oh, so it's going to change to plus 6. Yes, eventually when we solve it. Okay, so then let's go. We have y squared minus, because it's division, what do we have over here? A y squared, so it's going to be minus 2. So it will be 0. But hey, we just had this little talk about x to the 0 is just 1. Or y to the 0, doesn't matter. Okay, and then we have z. Was there a question?
Yeah, is that a 6? What is that after the 3?
It is a 6. Negative 3 minus negative 6. Yeah. So then we have z to the -5th minus, what are we going to subtract? -2. So that's what I meant by like just piecing it together. Okay. I say a lot of times it is a lot easier. Okay, so 34 and -18. Does that reduce? 2 would go into both of those. Okay, 2 goes into 34. How many times? 17. Okay, so this would be 17, and 2 goes into 18. Okay, so I've got -17 ninths. Then we've got x, -3 minus -6. Cameron said earlier this is going to change to positive, plus a positive. Okay, so it's going to be x cubed, y, 2 minus 2 is 0, and z, -5. Oh, we have a minus a negative, so we can change it to plus a positive again, a -3. Okay, so we're not quite done because we would want to replace this with just a 1, right? We don't need to write that. And we have a negative exponent. So let's change that up. We can keep our -17 ninths. Our x cubed is fine, or x cubed.
Do we even need to write the 1? Because anything multiplied by 1 is just itself.
Right, we don't even need to write it. You're right. Like this one here. Yep. Okay, so then where's the x cubed going to go to? Since it's
Right after it.
okay, but where's the z to the negative cube going to go?
Underneath it.
Because we need a positive exponent, and currently we have a negative exponent.
Wouldn't you just put the z and 3 under all of it?
The z and the 3 are going to go under, so z to the 3rd, which means our x should go on top, right? Because that's like what we're multiplying it by when we see it. So that's your final answer there, simplified.
Okay.
So still not too bad? Is that what I'm...
I mean, not yet, of course, Because I'm looking at number C examples down there, that's not looking too hot.
Okay, it's just getting, that's the thing, we're just getting more and more pieces to it.
Yeah.
Mm-hmm.
Me too. I kind of keep things simple, you know what I mean?
Well, again, like, we talked about yesterday, math is like a reflection of your life. Like, as you get older, life gets more and more complex. Like, so you're just practicing it every day in math. Like, you start with something simple and then it gets more complex. I mean,
Like what we did at the start of the lesson was like
it is good for your mental health, yes.
It was like the 32-piece Mickey Mouse Clubhouse jigsaw puzzle.
Yeah.
And now we're in like 1,000.
Well, you're like the new, jigsaw puzzle, yeah. I was thinking like crossword. I was like, yeah, it's like Sunday's crossword to what, Saturday's crossword I think is the hardest, and Sundays is always the easiest in the New York Times. Like they get progressively harder each day. So,
What are you talking about?
crossword puzzles, like New York Times, the crossword puzzles where they give you a clue and you have to write the letters in. But they get progressively harder each week. They start easy each week. Okay, so now we're going to look at the power of a quotient is equal to the quotient of the powers. So it's the same thing. We've done this. This is the thing here. When we have a over b to the power of n, it's just saying that n goes to both parts. We've done this. We're just putting words on it, or names on it now. Okay. Now, when we simplify an expression, like we can have x squared over 2x to the -3, or something like 2x to the -3 times y squared, okay, we can have a positive or negative exponents in the numerator. So we can have this negative up here and it be simplified. Ideally, it's all positive. It's preferable, but it can be. And then, but there's only positive exponents in the denominator. This is key. You can never have a positive or a negative exponent in the denominator and be simplified. It would be wrong. Okay. So that's all we're doing is looking at simplifying here. All right, so on A, we have y over x squared, all of that cubed. Well, we just, like, this just goes right back here. So this is going to be y what? Y3. x, okay, I'm going to write to the 2 times 3 so we can see, and then we'll go back and get to the 6th, right? Like we're just applying that to both parts. Just like here, the 2, does it just apply to the y to the negative 4th? On the next part, does this 2, where does it go to? To all the others. So this is going to be x to the 3 times 2 and y to the negative 4 times 2. It is a positive 2. So, okay. So yeah, let's go through and multiply. Okay, maybe I'll put a times sign back or in there. All right, so that kind of looks wonky. So how do I want to, because I have a denominator and I have, we can turn that into a fraction.
Can you put your y negative 8 down with the x6?
Mm-hmm. Okay, and then I'd have x to the 6th in the numerator, right?
Right.
And y to the 8th in the denominator. Well, do you need to rearrange it?
Yeah, you can put your x's together and your y's.
I can put them together? Okay, how do I put them together?
You're gonna multiply the exponents, right?
Well, this is division, so they would be subtracted. Is this simplified? It's not, because you have x's in the numerator and the denominator, and y's in the numerator and the denominator. The x's can totally cancel, right? We have 6 of them here, and we have, my pens are not changing color. It's frustrating. We have 6 here and 6 here. They totally cancel. Okay. Right, but we talked about at the beginning when they're divided, it is equivalent to y to the 3rd minus the 8. Yeah. Well, it was up here. That's not our answer. We would have to take that further. Well, you said the y to the negative 5th. Perfect. Both of these would be simplified because you can have a negative in the numerator, which is what you have right here, x or y to the negative 5th, or you can have positives in the denominator, so 1 over y to the 5th. Either of those is simplified. Yep. Yes. Okay. So do you want to stop here and you can start working on your homework, or do you want to go through B and C? B and C? Okay. Okay.
Just do C, or like, I don't know. Like, just do C.
Just do C?
I think B is like not too bad, but like C.
Looks like a mess. Yeah, we could do that. Okay. So with C, is there anything on the first part of C, the 8x squared z negative 3y? Is there anything to do to start? Okay, but so on the first, I'm saying on this first section, is there anything to really do? No, so it's just going to hang out for a while. Right, nothing can combine. There's nothing that really is being distributed. So I'm just going to write it down because it's just going to kind of hang out. All right, so then the negative 2, though, we talked about needs to be distributed to every single term inside there. So we're going to have y to the negative 2. And then we have z to the negative 4th times negative 2 over 2 to the negative 2 times x to the 5th times negative 2. right? So the negative 2 was distributed to, did I change color? Okay. The negative 2 was distributed to absolutely every term inside there. Okay, awesome. So then let's look at this. So now we've got still 8x squared z to the negative third over y times y to the negative 2 z to the, well, negative 4 times negative 2 is 8, okay, over 2 to the negative 2, wouldn't be negative 4. That's the tricky part. It's not going to be a positive 4. The negative, remember the negative in the exponent, so this is where it gets a little tricky. The negative in the exponent doesn't affect the number at all. 4, but it has a negative exponent. 4 to the negative 1, so we want to, that's fine. We can write it like that. Because we have to keep the negative exponent, because the negative exponent tells us, hey, I need to move this to the numerator. Okay, so I don't want you to get tripped up and then be like, oh, it's negative 4. Okay, like the negative on an exponent tells you location. All right, how about x? Negative 10th power. Okay. Now we have all of them in fractions. We've got some positive, some negative. Let's just write the fraction. Okay. Does the 8 stay above in the numerator? Does the x squared stay in the numerator? Yes. Okay. Does the z to the negative 3 stay? Okay, let's move it. Sorry, then it would be to the positive 3. Does that make sense? We can just move them? Or am I taking too big of a leap? Okay. Y to the negative 2? Or, okay, time out. Let me put my y. Let's bring this y down here. Okay. Y to the negative 2, where does it go? It goes on the bottom, right? We're just going to make that y squared on the bottom. We could. Okay. Z to the 8th stays on top. Make that. We're just going to have one really big fraction. Yeah, the things will just start canceling out. 4 to the negative 1 goes on the top because it has that negative exponent. So now it's a positive 4. Because it's already on the bottom, so we have to move it to the top. Just like the 10 is, or x to the negative 10. That's okay. Well, and that's like the one we talked about earlier where it was like 1/3 to the negative 2 power. We had to do the reciprocal. The reciprocal of 1/4, we don't look at it as 1/4. We just look at it as a 4 on the bottom sometimes, but it's actually 1/4. The reciprocal would have been 4 over 1. Okay. I'm running out of some room here. And there could be, I mean, like, there could be different ways that you guys go about simplifying these. But you're going to get the same answer. Like, you wouldn't have had to make it a fraction. You could have written this. I'll show you differently later, I guess. Okay, so now what? We can maybe cancel some things. Okay. And combine some things. So how about, what if we start with the 8 times the 4? That'd be 32. Okay. Then we have an x squared in our numerator. And then we have an x to the 10. So what should we do with those when they're being multiplied? Add them. So it's going to be x to the 12th. Okay. Then I've got a z to the 8th. I'm going to change up my color a little bit. Z to the 8th and z to the 3rd. And what do I do when I'm dividing with the exponent? Subtract. So that's going to be z to the 5th. We can. We just. Okay. And then Yeah, and that's going to be, where is that y to the third going to be? On the bottom, so we still have to have that. So then we're going to have y to the third.
That's it. Yay.
That's the answer.
Took way too long.
Perseverance.
How am I gonna get my summary done?
Now, what I was going to say about from this point. Okay, I don't want to confuse anybody, but if it would be easier for you, you could say, well, this is 8x squared z to the negative 3 y to the negative 1. Okay, you could bring it up. And you could do the same thing over here. Like you could leave everything, so then we'd have y to the negative 2, z to the 8th, 4 to the 1 power, and x to the 10th power. Because when we bring it up, we get rid of the sign, like we flip the opposite sign. And then from there, you could say, all right, well, this is 8 times 4. And then we have x squared plus 10. And then y, I jump to y. Okay, we have to the negative 1 plus the negative 2 power. And then we have z to the negative 3 plus 8 from this one. Okay, so that's still going to give us 32 x to the 12th, y to the negative 3rd, z to the 5th, which is also acceptable because I can have a negative in the numerator. That's okay. Or you could say, oh, wait, I don't like this in the numerator. It's going to be 32 x to the 12th, z to the 5th over y cubed, which is the exact same thing you got over there. Okay, so there you might, as you're working on them, you might find that you prefer to write them like this, where they're all like in one line, or you might prefer to write them as fractions. It really is up to you how you're going to do that and get there. Okay, that's why it's important to show your work so I can tell how you're solving it and answer questions. But how you necessarily get to the simplified answer will look different than other people's, and that's okay. Doesn't make it wrong. Okay, all right. Pretty much.
Hold on, don't erase that.
I won't erase it. And you might remember, you might want to cross out B since we didn't do that.